It is very hard for archaeologists to explain how that was done.
That's why I'm more interested not in how the Egyptians built the pyramids, but how the pyramids helped to build Egypt.
There is a quarry in southern Egypt where the desert floor is scarred with long, curving grooves cut into solid granite. Granite, one of the hardest, toughest stones on Earth. No steel, no power tools. And yet the marks are smooth, the channels are deep, and in one place lies a block of stone that would have been the largest single piece of masonry ever moved by human beings if it had ever been finished. This is the Aswan Quarry Complex, and for 2 centuries it has been one of the most studied industrial sites of the ancient world. Not because it's mysterious, but because it's one of the clearest windows we have into exactly how a Bronze Age civilization solved an engineering problem that, on paper, looks impossible, cutting and moving stone that is harder than the metal tools available to work it. You may have seen videos claiming this shouldn't be possible, that the marks are too precise, that an AI system looked at the quarry and returned some percentage of confidence that only modern diamond-tipped machinery could have made them. Those videos are not describing real findings. There is no published study, no peer-reviewed paper, no AI classification system that has concluded ancient Egyptians used power tools at Aswan. What actually exists is something better than a mystery. It's a solved problem, documented in exacting detail by archaeologists, geologists, and experimental engineers who have spent decades testing the real methods against the real stone. That story deserves to be told properly because it turns out the truth doesn't need embellishing. It's already remarkable. Aswan sits at Egypt's southern border, where the Nile narrows and cuts through outcrops of pink and gray granite, geologically part of what's called the Arabian-Nubian Shield, some of the oldest exposed rock on the continent. The Egyptians didn't choose this site by accident. Granite here is famously uniform, with fewer internal flaws than granite found elsewhere, which made it valuable for monuments meant to last forever. Obelisks, sarcophagi, statues, the casing stones of temples, and pyramid chambers. Quarrying at Aswan wasn't a one-time event. It ran for roughly 3,000 years, from the Old Kingdom through the Roman period, with different tools, techniques, and labor organizations rising and falling across that enormous span. That long timeline matters, because it explains something that often gets presented as a mystery: why cutting marks from different eras look different from each other. It isn't because an older, more advanced civilization vanished and left inferior workers behind. It's because 3,000 years of continuous industrial use naturally produced overlapping generations of tool marks, some fresher and better preserved than others, some reworked, some abandoned mid-process. A quarry used for 3 millennia will not look like a single, uniform event, and it doesn't. The centerpiece of the site is the unfinished obelisk, still attached to its parent bedrock. Had it been completed, it would have stood around 42 meters tall and weighed close to 1,090 tons, nearly twice the size of any obelisk the Egyptians ever successfully raised. It was abandoned partway through carving, likely during the reign of Hatshepsut in the 18th dynasty, after cracks were discovered running through the granite. This is, for researchers, an extraordinary gift. A finished monument tells you what the end result looked like. An abandoned one, frozen mid-process, tells you exactly how it was made, because the tool marks, the trenches, the pounding stones, and the unfinished cut faces are all still there, undisturbed since the day the workers walked away. And what those trenches show is not evidence of some unknown rotary technology. They show something far more physically consistent: repeated, controlled pounding. The primary tool used to shape granite at Aswan was a hard igneous rock called dolerite, sometimes referred to in older literature as diorite, a related, equally hard stone. These weren't the Bronze Age hammers imagined in some retellings, delicately tapping away. They were dense, rounded balls of stone, ranging from small handheld sizes up to pounders weighing several kilograms, used with 2 hands or larger versions swung by teams. Thousands of these pounders have been found discarded around the unfinished obelisk and elsewhere in the quarry. Not a handful, not a curiosity, but an industrial quantity, consistent with a large workforce using and discarding tools continuously over the life of a project. Egyptologists, including Reginald Engelbach, who conducted some of the earliest systematic surveys of Aswan in the early 20th century, documented this in detail. Later researchers, including teams working with Dennis Stocks, an experimental archaeologist who has spent much of his career physically replicating ancient Egyptian stoneworking, picked up where Engelbach left off and tested the method directly against the stone. Here is the key physical fact that makes dolerite pounding work. Dolerite is harder than the granite it's used against, but more importantly, granite is not a uniform, unbreakable slab. It's a crystalline rock made of interlocking mineral grains, primarily quartz, feldspar, and mica. Under repeated percussive force, those crystal boundaries fracture, and the surface breaks down into a fine powder, essentially pulverized rock, rather than shattering catastrophically. It's slow. It's laborious. But it is entirely capable of producing the trenches seen at Aswan, and controlled experiments have confirmed the removal rates match what a large, organized labor force could plausibly achieve within the known construction timelines of Egyptian monuments. Stock's experimental work, published in his book Experiments in Egyptian Archaeology, Stoneworking Technology in Ancient Egypt, is particularly important here because it didn't rely on assumption. He and his collaborators physically pounded granite with dolerite tools of the type and mass found at the site, measured how much material was removed per hour of labor, and compared the resulting surface texture to the ancient trenches. The correlation held. A great deal of the mystery framing around Aswan centers on the claim that the tool marks are too smooth, too curved, too geometrically consistent to be the product of hand tools. This deserves a direct, honest answer because it's describing a real feature of the site. It's just misinterpreting what produces it. When Egyptian quarry workers cut a trench around a block of stone, they weren't randomly hammering. They worked in organized rows, often multiple workers to a trench, pounding in a coordinated rhythm along a marked, pre-planned line. The trenches themselves are typically narrow, sometimes only wide enough for one or two people, and deep, following a pattern that was repeated across the site precisely because it was a standardized, learned technique, passed down and practiced by professional quarry crews who did this work for a living, not novices improvising. Repeated technique, by trained specialists, using tools of a consistent size and mass, following a standardized method, over a very long project. That combination naturally produces marks that look regular and rhythmic. That's not a sign of machinery. It's a sign of skilled, standardized labor, which is exactly what you'd expect from a state that could organize the workforce to build the pyramids in the first place. As for the curvature, dolerite pounders are round. A rounded stone struck repeatedly against a surface, removing material through pulverization rather than a single clean blow, will naturally leave a scalloped, curved impact pattern, because that's the shape of the tool making contact. It's the same reason a ball-peen hammer leaves rounded dimples rather than flat facets. This isn't a subtle point that took modern analysis to uncover. It's been part of the standard archaeological explanation for over a century. One claim that circulates is that some cut marks exist in spaces too narrow or too enclosed for a human to have swung a hammer, implying something else must have made them. In practice, ancient quarrying trenches at Aswan were made progressively wider as work went deeper, precisely because workers needed room to maneuver, and the archaeological record shows exactly this. Trenches widen with depth, and smaller pounders were used in more confined sections, with larger ones used where there was more clearance. This is standard, sensible workshop practice, not a physical anomaly. There's no documented case in the peer-reviewed archaeological literature of tool marks existing in genuinely humanly inaccessible spaces at Aswan. That claim traces back to popular online content, not to survey data published by the archaeologists who have actually mapped the site. Cutting granite was only the first challenge. The Egyptians then had to detach enormous blocks from the surrounding bedrock and move them, sometimes hundreds of kilometers, without cranes, pulleys of the kind we'd recognize, or wheeled vehicles suited to the terrain. Detaching a block relied on a technique that's been physically replicated many times. Workers cut a trench around the perimeter of the intended block using the dolerite pounding method, then undercut the base to separate it from the parent rock. Where wooden wedges were used, a technique long claimed in older popular accounts, where drywood is inserted into cut slots and then soaked with water to expand and crack the stone, the evidence is more debated among specialists than commonly presented. Some experimental work has questioned whether wood expansion alone generates enough force to fracture solid Aswan granite. And it's more likely the wedges serve to widen and direct cracks already initiated by pounding, rather than to split the stone from nothing. This is a live area of ongoing experimental archaeology, and it's a good example of how real scholarship handles uncertainty, by testing, publishing results, and revising conclusions, not by defaulting to unknown advanced technology whenever a question remains open. Once free, blocks were moved using massive wooden sledges, dragged over prepared surfaces. This is not speculation. It is depicted directly in Egyptian art. A well-known tomb relief from the 12th dynasty, showing the transport of a colossal statue of the official Jehuti-Hotep, depicts around 172 men hauling a sledge, with a worker standing at the front pouring liquid onto the ground just ahead of the sledge's path. For decades, this was assumed to be purely symbolic or ritual. Then, in 2014, a team of physicists at the University of Amsterdam ran controlled experiments and found that wetting sand ahead of a sledge measurably reduces friction, stiffening the sand just enough to prevent it from piling up in front of the sledge's runners, cutting the required pulling force dramatically. It's a striking example of how something that looks like myth or ritual in ancient art can turn out to be documented, functional engineering, once someone bothers to test it rather than dismiss it. For the heaviest loads, the Egyptians also made use of the Nile itself. Barges were used to float multi-ton blocks downriver during the annual flood season, when water levels were high enough to bring vessels close to the quarry itself, minimizing the overland distance blocks needed to be dragged. Multiple obelisks and colossal statues are believed to have made most of their journey this way. Popular retellings sometimes lean on the idea of impossibly small crews accomplishing impossible feats, which is part of what makes lost advanced technology narratives feel necessary. But the actual picture, based on settlement remains, worker cemeteries, administrative records, and ration accounts recovered from sites like Giza and Deir el-Medina, is one of a highly organized, large-scale state labor system. Not slave gangs, as older colonial-era narratives assumed, but rotating crews of skilled and semi-skilled workers, organized into gangs with names, overseers, medical care, and structured shifts, fed and housed by a centralized administration capable of provisioning thousands of people for years at a time. This is, if anything, the more impressive story, not a lone lost technology, but a functioning bureaucratic and logistical machine, a state apparatus sophisticated enough to plan, supply, and coordinate a labor force at a scale that wouldn't be matched again for a very long time. It's worth being direct about why claims of ancient power tools, industrial rotary cutting, or AI-detected, impossible precision don't appear in credible research on Aswan. First, there is no published, peer-reviewed geological or archaeological study using AI pattern matching software that has concluded the quarry marks match modern rotary or diamond-tipped tools. Claims citing a 94% confidence AI classification, specific variance percentages, or a named researcher having a dramatic reaction to the results are not traceable to any actual publication, institution, or dataset. That kind of specific-sounding statistic, presented with no citation, is a common technique in manufactured content. Numbers create an impression of rigor without requiring any actual source. Second, the physical evidence directly contradicts the impossible tools claim rather than merely leaving it unexplained. Microscopic study of ancient Egyptian cut marks, real studies conducted by geologists and archaeologists, consistently shows features fully consistent with pounding and abrasive grinding, crushed and fractured crystal grains, not the clean shear boundaries a rotary blade or diamond tool would leave. The tool marks match the tools found lying in the quarry. Third, the unexplained precision framing relies on comparing ancient work to modern hand tool experiments under casual, uncontrolled conditions, rather than to trained, repetitive, professional labor sustained over years. When Dennis Stocks and other experimental archaeologists tested the actual method, using real dolerite pounders, in the dimensions found at the site, with sustained repetitive practice, the results matched the ancient marks closely, both in appearance and in the rate of material removal needed to complete known monuments within plausible time frames. Fourth, copper tools also played a genuine, well-documented role, particularly for softer stones and for finishing work, but critically, copper alone cannot cut granite. What made copper tools effective against hard stone was an abrasive slurry, typically quartz sand, packed into the cut and worked with a copper saw or tubular drill. The sand did the actual cutting. The soft copper simply carried and pressed the harder abrasive grains against the stone. This is confirmed by drill cores and saw cuts recovered from multiple Old Kingdom sites, which show the characteristic spiral striations and embedded quartz fragments left by exactly this method. Not evidence of missing technology, but evidence of a clever, low-tech solution to a hard material problem, one that remained in use, refined and adapted for thousands of years. Claims that older cut marks are somehow more precise than later ones, implying a decline from an earlier, more advanced civilization, don't reflect the actual excavation record at Aswan. What is true is that different areas of the quarry were worked in different periods, using techniques that evolved, copper tools supplemented, and eventually gave way to more efficient use of dolerite pounding at scale. Iron tools appeared much later during the late and Greco-Roman periods, and different projects had different quality standards depending on their purpose. A quickly extracted block for a minor construction project was never going to receive the same care as a state monument intended for a temple or a royal obelisk. Comparing the two and calling it a decline mistakes purpose and investment of labor for lost knowledge. None of this diminishes how impressive Aswan is. If anything, it should raise your estimate of what the ancient Egyptians accomplished, not lower it. What the evidence shows is a civilization that identified a genuinely hard engineering problem. How do you shape and move stone harder than your metal tools? And solved it not with a single clever trick, but with a whole integrated system. Material science, in choosing dolerite specifically because it's harder than granite, metallurgy and materials handling, in combining soft copper with hard abrasive sand to cut where blunt force wouldn't work, fluid dynamics, in wetting sand to move. Sledges, centuries before anyone could explain why it worked. Hydrology and logistics, in timing transport to the Nile flood cycle, and large-scale organizational management, in running a labor system capable of feeding, housing, and coordinating thousands of workers over years or decades. That's not a mystery waiting for aliens or lost civilizations to explain it. It's one of the clearest, most physically documented case studies we have of pre-industrial engineering at scale, and it's sitting in the open desert at Aswan today, unguarded, unmysterious, and available for anyone to go look at directly. The pounders are still there. The trenches are still there. The unfinished obelisk is still lying exactly where the workers left it 3,500 years ago, telling anyone willing to look closely precisely how it was made. The real story doesn't need an AI to uncover it, because it was never actually hidden. It was documented, tested, and confirmed by generations of researchers willing to do the slow, unglamorous work of matching tool to stone, one trench at a time. And what they found is a civilization that didn't need machines it couldn't have had. It needed patience, organization, and a very good understanding of the material it was working with. It had all three.